Hey guys, it's Mary and welcome back to Study Journey. I'm back with another AMC 12 Problem of the Week video, and this is going to be about the volume of cones and finding the difference of ratios. So without further ado, let's get on with the video. This is AMC 12A, Problem 10 from spring of 2021. Two right circular cones with vertices facing down as shown in the figure below contains the same amount of liquid. The radii of the tops of the liquid surfaces are 3 centimeters and 6 centimeters. Into each cone is dropped a spherical marble of radius 1 centimeter, which sinks to the bottom and is completely submerged without spilling any liquid. What is the ratio of the rise of liquid level in the narrow cone to that of the wide cone? And your answer choices are listed below. So the key words are that these are circular cones and they are right circular cones. And then there is liquid inside these cones. So the radii of the top of the liquids are 3 centimeters and 6 centimeters. And then there is a spherical marble with a radius of 1 centimeter that sinks completely and is submerged. So the liquid is obviously going to rise. And this problem is asking what is the ratio of the rise of liquid from the narrow cone and then that of the wide cone. So here's the diagram, and this is the narrow cone, and this is obviously the wide cone. And then here is the amount of liquid, and that is radius of 3, and that is radius of 6. So if we're going to just find the ratio of these two heights, then we can list this one as the height for the narrow cone is h1, and this one will be h2. So to find the ratio of the height, we know the formula for right cone is going to be 1/3 pi r squared times height. So to plug this in, we can get, for the first one, we can get 1/3 of pi 3 squared times h1. And then for the wide cone, it would be 1/3 pi times 6 squared times h2. So if we're trying to find the ratio of these two heights, then we had to put these two into equations. So this can just equal the volume of the first cone, and then this can equal the volume of the second cone. So now we can find the ratio. How do we do this? Well, we can put h1 by itself. So h1 would equal the volume over 1/3 pi 3 squared, and then h2 would equal v2 over 1/3 pi 6 squared. And it says that the amount of liquid in each of these are the same. So V1 is equal to V2. And if we're going to put H1 over H2, then we get, and then we can simplify this and get, further simplify, and we can cross out the 1/3 and pi's because they cancel out. And then this would equal 36 over 9, which equals 4 over 1. So the ratio between the height of the first cone and the height of the second cone is 4 to 1. Now it is asking what is the rise of the liquid. So we know that the spherical marble has a radius of 1. So what this means right here is that it is the same marble that is being dropped into these two. So the rise of the liquid for these two are the same since it is the same marble that is dropped in there. So this ratio right here actually doesn't change. So the rise of the liquid is the same as, so the ratio of the rise of liquid is the same as the ratio of these two heights. So the answer would just be 4 to 1. Taking a look at our answer choices, we can see that the answer would be E, 4 to 1.